Hello, I'm David Brown from the Solidworks training team. This video presents a project that you can use to hone your Solidworks skills and is easy to make if you have a basic 3D printer. I was getting ready for this spring season of fishing and needed to replace the line on my reels. Rather than asking someone to hold the new spool or propping it up with a makeshift error-prone system, it occurred to me that I needed a more reliable method to help hold the new spool. So I fired up SolidWorks and came up with a handy design and printed it on my 3D printer. The key aspects of this design that I will focus on are design intent, features, exporting solid bodies, hardware, assembly, and 3D printing. Let's get started. I designed the fishing line spooler to handle most of the standard size spools available at the local tackle shop. Changing the spools needed to be quick and easy. The rod needed to snap in place. The hardware is standard and readily available. The design needed to be able to handle the variety of spool sizes, yet only require one size spring. The springs hold tension on the spools, preventing the line from running away and creating a tangled mess during the spooling process. The device should be able to be mounted to a bench, wall, under a cabinet, or simply clamped to a bench or table using a spring clamp. With the exception of the purchased parts, the main components are suitable for 3D printing with minimal waste. I used multi-body part techniques to design the main body. This resulted in 4 parts. The swivel, body, and cap are all 3D printed. The 4th body is a representation of the rod. By creating it here rather than in a part of its own, I can take advantage of SolidWorks' parametric capabilities, ensuring that I have an accurate length of the rod. The first thing I'd like to point out is that this model is symmetrical. As such, I want to take advantage of that and make sure I have the origin in the middle of the part. This way I can leverage the default planes. I'll just hide these for now to make things easier to see. The first feature is the base, and is oriented so it sits on the top plane, centered at the origin. For the upright, I place the sketch on the right face of the base feature and extrude the profile a ½ inch, followed by a 1-inch circle extruded 3½ inch up from the bottom. Using the right plane, I mirror these 2 features to the other side. For the rib, I put a sketch on the front plane with a single line and use that to create the rib. I created 2 extrude cuts to accommodate the swivel. The first is an offset circle on the top of the upright, extruded down 3/8 of an inch, followed by a hole for the threaded brass insert. The brass inserts that I buy are metric, so I make the hole the diameter of the insert at a depth that is a little deeper than the insert would go. The next step was to design the swivel. As you can see in these cutaways, the design intent of this part is for it to be attached to the main body with the machine screw into the threaded brass insert. There must be enough clearance for the rod to be inserted above the head of the screw, and the rod is then press fit into the swivel component. I want the swivel to rotate freely, so I use small offsets in the sketch profile. Notice there are only 3 dimensions in the sketch. These are the critical dimensions of the swivel component. The rest of the sketch is fully defined with sketch relations. I then use this profile for a revolve feature and make sure I uncheck Merge Result to create a separate body. The next 3 features are the cuts to accommodate the screw and rod, based on the design intent just mentioned. The first hole needs to have enough clearance for the diameter of the screw head and be high enough above the top of the upright to accommodate the length of the screw. The second hole is a clearance hole for the screw itself, and the third hole provides the necessary clearance for the rod to clear the top of the screw head. To finish off the right side, I made a cap that will be glued in place with epoxy after assembly for a clean look of the design. The cap is a separate body with an extruded post on the bottom to fit into the hole. I used a slight draft which provides a little room for the epoxy. Once the right side is completed, I simply extrude a circle on the top face of the left side up to the top surface of the cap as an end condition. This makes both sides the same height when completed. I need to have a flat face on each of the uprights for washers to rest on. I accomplish this by inserting a plane that is parallel to the right plane and tangent to the upright. For the right side, I place a sketch on the new plane and using converted entities and relations, extrude up to the surface of the swivel body. I repeat the process for the other side. The circle is a converted entity created from the corresponding feature that was just created on the right side, and again, extruded up to the surface of the upright. On the left side, I need a slot for the rod to snap into. I make it slightly larger than the rod diameter for clearance. Notice there is only one dimension. This is the critical dimension. The rest of the sketch is defined using relations to surrounding geometry. This takes full advantage of Solidworks' parametric capabilities. The next feature is a small bump on the underside of the slot for the rod to snap into place securely. When I use this device, I simply use a clamp to hold it in place at my workbench or kitchen table. But I also felt it would be good to be able to mount it to a bench, a wall, or even under a cupboard. I used Hole Wizard to put a pattern of countersunk holes for this purpose. To create the rod, I placed a sketch on the right plane with a circle the same diameter of the rod, positioned with a coincident relationship to the center of the hole in the swivel, and a mid-plane extrusion the appropriate length. Again, I uncheck Merge Result to create a separate body. Even though I make the rod from a piece of purchased steel rod cut to length, creating it here in the model helps me to visualize my design. The last thing I do is add some fillets to finish off the design. As these are not critical to the design, use whatever sizes you feel are appropriate. Now that the components are finished, I want to save the individual bodies to separate files and save them to a format that my 3D printer will understand, an STL file. For this, I will utilize the Insert into New Part command. Using this method will allow me to create an assembly with the components and then generate the STL files. I'll expand the Solid Bodies folder, right-click a body and choose Insert into New Part from the context menu. Next to Title, I click the button to browse, name, and save the file. Then click the green check to initialize the command. This creates the part file and opens it. Notice the Feature Manager design tree has one feature called Stock with the file name of the part file it is derived from. With this file open, I'll choose Save As and select STL for the type and click Save and then Yes to dismiss the message. Now I will return to the master part and do the same thing with all the other bodies. Part of the design process is to bring it all together in the context of an assembly, to make sure the design will work properly. For this, I created a representation of the brass insert, a spring, and the washers. I used a screw from the toolbox in Solidworks. I found a suitable spring at a local hardware store and with my calipers measured the size to be 1/2 inch by 3/4 inch long. With such a small spring, I needed to make spacers to make up the difference to accommodate the different size spools. I wanted to be able to see in the model what the spring will look like under different compressions. So I created the spring with 3 configurations: default or uncompressed, half compressed, and fully compressed. The spacers were also created as a single file with 3 possible configurations, using a simple revolved profile. These were also 3D printed. Bringing all the components together in an assembly allows me to test the form, fit, and function of the components. In addition to creating the spring and spacers with configurations, I also created a representation of the spools with configurations of their own of each of the 4 possible sizes. Because of this, I'm able to create configurations in the assembly file to represent the 4 sizes as well. This design has a few parts and very little need for support material. I printed the spacers and cap in one print. The cap is printed upside down to accommodate the post, The body has one small area that creates an overhang. My slicer has the ability to create generative organic shapes for support and is the best option in this case. If I were to use the default option for supporting this area, support material would be attached to the part and is more difficult to remove from the ledge. Using the organic support shapes eliminates the need for scraping support material from the ledge. For the swivel, I orient it upside down on the printer and use the organic support options as well, resulting in a nice clean part. I purchased a standard 3-foot length of 1/4-inch steel rod from my local supply store, cut it to length with my angle grinder and a cutoff blade, beveled the ends, and cleaned it up with steel wool. To assemble the physical unit, the threaded brass insert is tapped into the body with a small hammer. The swivel attached with the screw, then the rod is tapped into the swivel with a small hammer. The cap is glued in place with epoxy. All that is left is to add the washers, springs, appropriate spacers, and a spool of fishing line. This is a great little project that provides a solution to an everyday problem very well. It is also an excellent exercise of using multi-body part design in Solidworks, configurations in parts and assemblies, and representing purchase parts and using them to test form, fit, and function within the context of an assembly. So fire up Solidworks and design a reliable fishing line spooler yourself and get out on the lake. Thank you for watching this video. Stay tuned to this channel for upcoming projects in the Useful Solidworks Design Projects You Can Make playlist, and if you found this content helpful, visit the site below to access more content for designing with Solidworks.